Explain the terms inductive and electromeric effects. Which electron displacement effect explains the following orders of acidity of carboxylic acids? Now, second part, let me answer first. You find that both these effects are explained very well by inductive effect. How is it? I'll just show you. The logical portion I'll just answer first. You have CCl3 COOH. Now please note, this has withdrawn electrons. Oxygen withdraws from hydrogen, fine. And you find that this group, these chlorines, since these chlorines are taking electron cloud away from carbon and it is withdrawing from here. If you have electron withdrawing groups which are taking electrons away from acidic hydrogen, then acidic strength increases. So if you compare this with another molecule which has only 2 Cl atoms, obviously 2 Cl atoms do not have the same withdrawing power as 3 together. So they can withdraw only as much. So acidic strength would not be as great. And if you have only 1 Cl atom, the withdrawing power would be still less. So as the number of -I groups Cl atoms increases, a negative inductive effect of -I effect increases, and that increases the acidic strength of these carboxylic acids. Oh wow, that is the case? Yes, that is the case. Opposite is the case here. You have COOH, wonderful, and then you have CH2, wonderful, and then you have CH3. So it should be written as, something like CHHCH3. Fine. If I replace these hydrogens by more and more methyl groups are electron releasing groups. So I'll get HCCH3CH3 COOH, which is this. And if I write all 3 methyl groups, I'll get this CH3 C CH3 CH3 COOH. So please note 1, 2 and 3 methyl groups. Methyl groups are +I groups. They're electron releasing groups. So if they release electrons, please note this is the acidic hydrogen. If electron releasing groups are attached to the other part of the acidic hydrogen, then they decrease the acidic strength. So if they keep on releasing, 1 methyl releases a little, 2 methyls release more, 3 methyls release still more. You'll find acidic strength would decrease because of +I effect. So this is -I of Cl and this is +I of methyl groups, which explains this order of acidity. As for what exactly is inductive or electromeric effect, take a look at the theory. I'll just move away from screen so that you can enjoy the entire theory properly. I'll keep speaking. If you just look at -I effect, permanent displacement of sigma electron cloud in one direction because of attachment to groups of different electronegativity, that, my dear, is called inductive effect. If a species withdraws electrons, it is said to show -I. If it releases electrons, it is said to show +I effect. And this is how one would represent the answer. You can take a screenshot in case you need, and you have this. And then the second part, electromeric effect. What is electromeric effect? Temporary displacement of pi electron clouds. If pi electron clouds jump on one side simply because of interaction with another species, another molecule, another ion which is approaching them, that is called electromeric effect. Pi bonds may jump on one side, then they may come back. It's a temporary effect, right? And again, if electrons move away, it is +E. If the electrons move towards a certain species, that is called -E effect.